This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 51, representatives from PADT's tech support team talk Ansys Discovery products at 2019 R3, along with a look at Ansys Inc.'s Q3 results. Welcome to this mid-November version of our podcast. We had a really good but very long discussion about Ansys Discovery today for this podcast, and because there was so much to discuss, and then I want to review the numbers from the Ansys Q3 discussions. So instead of going on about introduction stuff and all that, and a lot of news and articles, we're going to cut it really short. We're just going to do the interview, and then I'm going to talk about what happened with the Ansys stock and their Q3 information. I will add that we did cross the 15,000 downloads last week, as hopefully predicted at episode 50. So that milestone was reached with both those round numbers of 50 episodes and 15,000 downloads. So let's get on to the interview, and for this episode is really a discussion, not so much an interview. We decided to make this podcast about the new features in the Discovery family of Ansys products at the R3 release for 2019. And usually that's a fairly short discussion, but there's a lot in there. The products are SpaceClaim, Discovery Live, and AIM. And once we started preparing, we found that it was just chock full of things. There was a lot to talk about, so we did. But please listen in, and hope you learned something like we did.
Welcome to our podcast. I am very pleased to say we don't have just one, not two, not three, but actually four of our technical support engineers on the Microsoft Teams with me today to talk about one of our favorite topics, everything in the Discovery products at Ansys. So let's just go around the virtual room, starting with Joe, then Tom, then Rob, then Ted. Why don't you go first, Joe, and introduce yourself and tell us about your Ansys background.
All right, I'm Joe Woodward. I'm Senior Mechanical Engineer and Lead Trainer here at PADT. I've been using Ansys for 23 years, mostly structural. We'll go with that.
Good.
Okay. This is Tom Chadwick. I'm one of the Senior CFD Engineers here at PADT. I've been using CFD for a little over 30 years and Ansys for probably about 15, 20 years of that.
Cool. And Rob?
I'm Rob McCathren. I've been PDT for a year. I'm a new application engineer. Previous to that, I'd been in the offshore industry for a little over a decade and used Ansys all throughout that time, primarily doing structural work.
Mm-hmm. Well, in fact, is this your first podcast? I can't remember.
It's my first podcast.
All right. Well, welcome to the podcast. So we'll take a little bit of time for a little bit more background. What industries did you work in before coming here?
It was, maritime transportation, offshore oil and gas. And so the maritime transportation is more like ship design.
Okay.
But I started off at a small naval architecture firm in Houston. Okay. And just got to wear a lot of hats. So, mm-hmm. And when I was there, I was very quickly the Ansys expert, because the only person that had any more training than I had about like a weekend more training. But I actually used APDL in school, and that person had never used anything with it. So it was trial by fire. Moved from there doing some, went to a rig design company that had, their jackup rig designs are the basis for like a third of the world's jackup rigs kind of thing. Okay. And from there, I went to a company called Dockwise that was doing, very large floatovers. So if you needed a rig taken from a shipyard to a location, or, a cruise ship, whatever, boats, barges, they would put it on their vessel, mm-hmm. ballast the vessel down, and then put it over, deballast, and send it on its merry way. So I was doing the structural bit of that to make sure, our ships weren't too close to capacity. And then from there, I worked at a subsea company, mm-hmm. DOF Subsea, and we were just doing some operations side of work, so sea fastenings, things like that. And then I did a little bit of work on my own, some contract mm-hmm. consulting work, and found myself at PADT.
Great. So you're one of the rare PADT employees that lives near water. So that's your background is very different because of that.
Water, what's that?
What's that? Exactly. So, it's great to have you. And you work out of the Houston area and support our customers all over our territory, but mostly in Texas. Is that correct?
Correct. I found myself traveling between Dallas and Houston and Austin. But mostly Houston.
Mm-hmm. Cool. Very good. And Ted, why don't you reintroduce yourself?
So I'm Ted Harris. I manage our simulation support group here at PADT. A longtime Ansys user, contemporary of Tom. So I've been using Ansys tools for 30 plus years. And I'll just say, those of us here in the PADT headquarters in Arizona is the place where rivers and bodies of water are not associated with each other.
Right. That's exactly right. Often our rivers are just dirt. It's so true. And I'm Eric Miller. I'm one of the owners here at PADT, and we'll go ahead and get started. And I'm going to try and be more disciplined. When I get excited about all this new stuff, I tend to bounce around a little bit, but we'll go ahead and start with just talking about what's new in the SpaceClaim product itself. And for those that aren't familiar with SpaceClaim, it is the solid modeling tool for Ansys that is getting to be more and more than just a solid modeler, and we'll talk about that. But it helps you prepare your geometry, modify your geometry, drive your geometry, do 3D printing, do optimization, all sorts of cool things. So it's grown since Ansys acquired them quite a few years ago, and we're really excited to see there's a lot in this R3 release, 2019 R3. So who wants to tell me their favorite, go first and tell me their favorite addition in R3 2019 for just SpaceClaim?
Oh, I can go first, Eric.
Sure.
So I'm a big fan of the beam modeling coming from the ship side. So we do a lot of beam and shell modeling, and just seeing their new features there just makes me wish I had that years ago. Speed things up quite a bit. Because like a big thing they have. So with the selection filter, you can now select beams through that, and it's power select through beam length. You can also exposes the mass properties of beams and shells. So before you would just get like an area, and now you can actually get mass properties of those things. And there's a little bit better display, and now you can also orient beams to cylinders, whereas before it didn't really behave correctly. So now you can get that behavior down.
Cool. And is it like in the FEA package where you're representing it as a line in the CAD package and you assign a cross section to it? Is that the way it works?
Yeah, correct. So when you make your lines, you can assign cross sections, and the cross sections will pop up as another little sketch.
Okay.
As another little tab within SpaceClaim, and from there you can make your sections from there. And so that's what retains that cross section information.
Cool.
Although one of the best things in SpaceClaim is the ability to extract the cross section from a 3D solid model.
That's true
you
too.
Can just click on it and it pulls that center line and the full cross section for you. So it does really well.
It's been a very long time since I've done a beam model. So I remember it being extremely painful to extract the center line and then the cross section. So you're telling me that you can pretty much just click in there to get the center line and then also click to get the cross section.
Right. You can just click away and it's really fast. Really.
So even if you're using an antiquated solver, not from Ansys, like begins with the letter N, you could build your models, your shell and beam models using SpaceClaim probably, and speed up instead of using that ancient tool that they have, right?
Right, definitely.
Yeah. In fact, when I worked at a previous company, that's what they would do. We had our group using Ansys and another group using that antiquated program. And so we would make our models in SpaceClaim and then send them over, and they would wonder how we got them done so quickly. Yeah. That's really cool. So it's a whole area of simulation that we don't talk about too much here. But modeling things as beams and shells is not going away. It's still a really powerful way to get a more accurate and more efficient model. So it's good to see that they're working on that. Cool. What else? Who's got something else?
Well, my favorite thing is the auto skinning to put surfaces on an STL file mesh that's been brought in.
Or
the
an
auto skinning.
right? An old FEA mesh as well, right?
Right. Or results from the topological optimizations.
Okay.
That's the big one. Instead of, they've been adding to their capabilities all the time of being able to make patches and surfaces on the STLs. Now there's auto skinning that will just go through and do it for you, basically. It makes all the surfaces tangent right now. So it's best for organic type things with the topological optimizations. But I was told they're working on getting it where it'll make flat surfaces for the machined areas and things like that.
You can specify an edge and say, make this a sharp corner, or
Right. And that's coming in future versions. But right now it does very well for, it's very quick to get a solid model off of an STL.
In many ways, this is a holy grail that's been around since we started doing 3D solid modeling, is the ability to go from a mesh, a faceted surface representation, to a NURBS-based patch representation. So they've come a long way. It's an impressive tool, and it's fairly fast. The little bit I looked at it seems like it went pretty quick, which was back when I've looked at these tools in the past, they took a little while.
Right. They're faster than they used to be. They still slow down when the mesh is really large, but they're faster than they used to be.
And how does it so you've used another tool that we resell called, is it DesignX now?
Right.
How does it compare to DesignX now? Is it getting close to that capability?
It's getting close, yes.
Yeah,
it's getting closer. DesignX was built from the ground up to do those types of things. So they are catching up, but they're catching up quickly.
To me, that's the kind of the benchmark is we use DesignX to go take our scan data usually and convert it over, and had to use a specialty niche code to do it. And now it looks like we are able to get really close with this auto skinning. So that's a cool one. How about you, Tom or Ted? What do you guys think?
I'll defer to Tom, unless.
Yeah, Tom, what do you got? What's your
I've just been looking through this, and it's got a lot of stuff about editing facets. So if you can clean up geometry that's faceted and create smooth surfaces over it, that's a pretty nice
support on line 1
feature.
Support on line 1.
Should we stop?
Engineering.
I don't know how we mute our phones.
Should we point out that all of the tech support engineers are on this podcast right now?
That's what I was going to say earlier.
I'm sorry if one of the listeners. I'm sorry if one of the listeners is one of the people calling in right now. We got to take a break at some point.
Well, not all of the support team is on this podcast.
About half.
And somebody got the call. It looks like so.
Yeah, Doug and Sina and Seema, and there's a bunch that are actually about half of us. But you bring up a really good point, Tom, because not only is it useful for those of us that work with meshes, but it's very useful for those of us who work with STL files or scan data.
Right.
So using SpaceClaim as a way to deal with legacy meshes, data that you're getting as an STL file, even kind of cheap online CAD systems. If you've got a customer that's using something that only outputs facets, there's a lot of capability there. Pretty excited about that. Ted, do you have one?
Well, I think some of the things we haven't talked about are improved rendering and enhancements to meshing that you can now do in SpaceClaim. So if you're not aware, SpaceClaim has meshing capability. And that's been enhanced. But I think those things will be easier to see on the upcoming webinar.
Yes.
But one thing I think it's good to point out, and maybe this will transition us to the next section,
yes,
is when you're running Discovery Live, that is really running within SpaceClaim. SpaceClaim is the envelope in which Discovery Live is running. So all of the Discovery Live capability is encompassed within SpaceClaim, and all the SpaceClaim capability is there within Discovery Live. So if you're using Discovery Live and you just move your mouse up to the top, the SpaceClaim menus are all right there. And in fact, when you save your project in Discovery Live, it's a SpaceClaim extension. So it's really one and the same, other than with Discovery Live, you have the additional solving tools.
So integrated in there. Yeah, so it's CAD based simulation, but we're starting with the simulation.
Right, and so the reason I think it's important to mention that is because if you're going to use Discovery Live, SpaceClaim is a big component.
Huge.
That's part of it, and therefore it's important to know what's in SpaceClaim and how it works.
Very, very true.
Hopefully I said that right.
Yes, yeah, I definitely think so, and it's something that I think people, when they use it, they'll get it as well, because you'll be like, oh, okay, now I understand. So my favorite thing before we move on to Discovery Live is scripting, which I'm a huge believer in scripting, and was a big advocate for them adding scripting to SpaceClaim, which they have been working on quite heavily for the last couple of years. It's Python, if you haven't looked at it yet, and for those of us that kind of grew up creating scripts to do bottom-up geometry creation and do fancy things where we have programs that modify geometry. Scripting is really important to create that geometry and modify it. And boy, this is scripting on steroids. So not only is it Python, but we have access to a really good solid modeler. Two things that were added at this release is we can now do selection filtering, which is critical. That's how we figure out where we're going to apply a load or something like that. And one that I'm really excited about is that you can do measurements in SpaceClaim, and now you can grab the results of those measurements. So we can look at the distance between 2 points, make that a parameter, and then do something with that value. And if you start thinking about automating things or adding functionality, like maybe you've got some fancy load that's dependent upon two totally unrelated, the distance between two totally unrelated points, you can now script that in. It's pretty cool stuff.
Big one for me was you can now convert a selection. So you could script in selecting a face.
Yes.
And then convert to the edges of that face.
Right.
Which in the past was a little bit difficult.
Yeah. So that's a key selection algorithm that we use, right? Is we may grab a surface and then get the edges of that surface and then maybe grab the next face over. So now we can do those kind of things. It's pretty powerful. There's a bunch more, like Ted said. Definitely tune in for the seminar or the webinar that's coming up to see the visuals. There's some cool animations of all this, and you can get a feel for it better that way. But let's shift gears and talk about the coolness that is in Discovery Live. And as background, a little bit about Discovery Live, if you're not familiar with it, it is a new solver technology. Well, it's not a new solver technology, but it's new to Ansys that solves on the GPU. So it's massively parallel solver technology. And it is almost or is real time in its solution for thermal stress, fluid, and now some electromagnetics. Is electromagnetics working yet on this version, R3?
Electric conduction.
Electric conduction.
And one you left out is modal.
Modal, thank you. For structural. Yeah, modal is really, really important. So this is really becoming a more and more powerful tool. It is really oriented towards the design engineer to explore their designs in real time while they're building and designing things. And we love it. We love Discovery Live. It's super cool. So what is your guys's favorite thing? Maybe we'll go backwards this time. Maybe we'll start with Ted. Do you have a favorite in Discovery Live?
Yeah, I'm going to say it's the new vector display for fluid flow simulations.
Okay.
I was at a customer just a few days ago last week, and we were giving them some training on Discovery Live, and we were using 2019 R3. Mm-hmm. And when we got to the fluid flow and we turned on that new vector display capability, it was really just jaw-dropping what the visualization of the flow in their device looked like.
Mm-hmm. Mm-hmm. I just realized that the example that they give is the Lego race car, the CFD of the Lego race car. That's pretty fun.
Yeah. And I think it looks similar to the streamlines, but the difference is if you have internal flow, the vectors really fill the entire flow volume, whereas the streamlines are really dependent on the source of the stream and where you position them, and they don't necessarily fill the entire flow body. But the vectors do.
They tend to disappear right where you want them. It's always been my experience.
Yeah. Well, I mean, it's not that they're not valuable. They just give you different information.
Mm-hmm.
So it's really nice having this additional way to visualize the fluid flow.
Yeah, I agree with that one. How about you, Rob? What do you got?
Oh, let's see. I was liking the exposure to the minimum feature size. So you can preview it graphically first, so you can see it actually in the model. Because prior to that, it's just kind of playing with it, especially on the structural side sometimes, to see what's included here and there. What was one other thing I was looking at? It was the...
No, you only get one.
Okay, result contours. I'll go with that. That's it. So the
result contours is cleaned up. Yeah.
New guy gets two.
Blended. Yeah.
New guy gets two. Yes, and they were two small ones. So we'll give it to you. But yeah, I think that they're both they are small, but they make a big difference from a usability standpoint. I mean, if you're a design engineer and you want to know where that minimum feature size is, it's really, really handy to turn that on and visualize it, because it's kind of sometimes it's not all that intuitive what that is on your part, because you may have big chunky parts and little fragile parts in the same component. So this helps you visualize all that. And then on the visualization of the contours, that was one of my pet peeves, is I just didn't like the way it just like, guys, I don't know. It looks kind of funky, like it's some artificial results there, and they've kind of gone in and cleaned that up. And there's a really good example in the webinar that they'll go over, that you can see exactly what we're talking about here. What about you, Tom? What do you think?
Well, one of the big things for me is the fact that up until this point, your boundary conditions for fluid flow were constant values.
Yes.
And now they give you the ability to put in a time varying input, so you can see like a pulsing inlet where the flow is varying in some kind of a sinusoidal fashion, and you can see how the flow behaves with that.
It's
varying.
Yeah, it's always been
it's
always been transient. It's just that we couldn't have a transient boundary condition before. So being able to turn that on is really cool. Yeah.
Right.
I agree. And you should definitely just attend the webinar just to see the animations. The visuals of that are pretty cool, because you kind of insert fluid and kind of see it travel through a device. It's pretty neat stuff. Yeah. I think it's temperature they're showing in there. What about you, Mr. Joe? What do you like?
I think my favorite's the topological optimization.
A lot of enhancements there.
It's released in this version, but then they also have a beta feature of multiple load cases. So you can load your part up in different scenarios and get a topological optimization that handles both cases.
That's always been an issue of mine with topological, is you've got to look at all the different load cases.
Right.
So that's really key. Good. There's a lot more in there, right? I mean, not only is that there, but it's just like, it seems like the algorithm is more efficient and kind of gets to, I don't know, better looking geometry. That's totally a non-scientific term, but
right.
I feel like it's just more robust. It's curious to see how people are using it as time goes by. The big advantage because of course we have topological optimization in mechanical as well, is the speed. It's really fast, and it may not get to the refinement that you're going to get in mechanical, but boy, I'll tell you where you need to remove material really quick. Anybody have anything else on kind of what's new in Discovery Live? You guys covered everything I was excited about. I mean, rendering's better. I don't really care about that.
Although they do show quite a few really cool looking pictures. You can see the change.
It's when they first introduced Discovery Live. I saw it before it had been named. It had some other name that I can't remember now. And they put me in a room and made me sign a special non-disclosure. And they said, stop. Before we show you this, you need to stop thinking like a simulation guy, like an analyst. And I still struggle with that. So I need to let go of it having good renderings doesn't make me less of a real engineer. So I think that's really, really good. Yeah. Did anybody have a chance to really look at the calculators? I think those are new at this release as well, and I haven't had a chance to really look into them, so I'm not 100% clear on what they do or why we care.
There's some calculators already been in there in previous versions. Just now they're doing it like you can measure like difference between like different conditions of different BCs. Okay. Before you would just have like one single, like, hey, I want to do this result at this BC, but if you want to know the difference between the two, like if you're looking at, differences in flow between outlets, et cetera, you can do it that way.
So you don't have to script it or do it in Excel. You can actually do that difference calculation right there.
Correct.
Good. Okay. Good. Okay. Anybody have anything else before we move on to our last topic of the Discovery suite of products?
Well, I think it's probably good to mention that in Discovery Live, you don't see the mesh.
Right.
You have access to a slider that is speed versus fidelity. And so if you move it toward speed, you get a faster solution. And if you move it toward fidelity, you get what's probably a more accurate solution at the expense of additional computational time. But normally that computational time is still very fast compared to traditional types of simulations that we might do. But I think it's important to point out that the accuracy of your solution is really dependent on the amount of video RAM you have in your GPU. That is really the sole factor that determines how much refinement, shall we say, that you can put into your mesh. There's really no other knob besides that speed versus fidelity slider. And of course, the other thing is the geometry you're putting in. So if your geometry has lots of bodies, and especially lots of thin bodies, the code may not be able to adequately resolve the model you've got with the amount of video RAM that's in your GPU.
That's a really good point. Let me riff on that a little bit, in that we have to remember that this product is really oriented towards design engineers. So let's hope their company has spent money on a really good graphics card, but there's no point in investing in the tool if you're not going to invest in a graphics card as well. I think that's really, really important. You can get yourself disappointed.
Right. So the guideline is a minimum of 4 gigabytes of video RAM in your NVIDIA card.
Okay.
But if you have more video RAM than that, all the better.
Yeah. So if you can get an 8 gig card, and then really think about the payback, the ROI on that's pretty quick, because if you're a design engineer and you're trying to figure out, just kind of rule of thumb, do I have enough? Am I constricting flow with this design? Am I going to break this thing? If I change the thickness of this, is it going to impact my deflection? These are the sort of things you can do in real time by just, dragging geometry and seeing a change in results. And it's exceptionally powerful, but you got to have that graphics card. It's how it works, because it's massively parallel. Good point. And good one to end on for that section. So the third area within the Discovery family of products is Discovery AIM. Does anybody remember what AIM stood for? Was it Ansys Integrated Modeling or something like that? I don't remember.
Something like that.
Something like
that.
Go
with that. Sure.
I think we can go with that. Ansys something. So AIM is kind of between the Discovery Live product, which is, really oriented towards design engineers, and Ansys Mechanical, which is oriented towards the analyst that may be part-time or full-time. It's the nice user interface. AIM is kind of oriented towards the new user that kind of steps you through the process of building and running your models. But under the hood is the full Ansys solvers. So you're solving the same way as in Mechanical and Fluent, et cetera. You're just using a different user interface to get there. We really recommend AIM for companies that are occasional users or where they are new to simulation. It's a great place to start using simulation. So, having done that preamble on what AIM is and 2019 R3, who wants to jump in with your favorite feature?
I'll start first on this one. They've added in linear buckling.
Yay!
They keep adding capabilities with each release, and this time around it's the non-linear, or not the non-linear, it's linear buckling.
Linear buckling, yeah.
Analysis to find your stability and of your load on your structures. So
Find out at what load is this thing going to buckle, right?
Right.
Yeah, it's an important calculation, especially in the structural world, right, Rob?
Yeah.
Yeah,
absolutely.
Yeah. We don't like buckling. Buckling tends to lead to failure.
Buckling bad.
Buckling bad. How about you, Tom? What's your favorite thing in there?
There's a lot of capability in terms of improving the quality of mesh, especially boundary layer meshes.
Yes.
It used to be that there's problems if you went from a circular duct to a thin duct, that you would have problems with the mesh, the inflation layers collapsing out. But now the code is aware enough that it recognizes the fact that you're going into a different region and compresses down the element sizes or mesh sizing and allows you to maintain the boundary layer mesh down into very thin ducts.
And that's a beta feature, right? I think.
Yeah, it's
enhanced physics-aware meshing for fluids, right?
Yes.
Yeah. The picture they show in the documentation reminds me that I need to vacuum upstairs. But it is a great example, right? If you vacuumed, you've got that tool that's kind of round that goes on the end, and then it's got the flat part that you use to stick in between the couch cushions. It's
also big if you're doing like air conditioning ducts. Yep. Very often you see the grocery stores and stuff like that. They have what they call curtain air conditioner ducts that have that will create a thin sheet of cold air, and it's specifically designed for those kinds of geometry configurations. Or for automotive, another application where you're dealing with the flow coming from a circular duct from the compressor and then being pushed out into the internal cabin of the car. And very often those ducts have pretty radical shape changes.
And one of the things that all of the simulation companies out there have learned, Ansys has been a multi-physics code since the APDL days. So we kind of grew up knowing that meshes are different for fluids versus electromagnetics versus structural, right?
Yeah.
And I think this is a good example of Ansys's understanding of that, and that they've got this physics-aware capability to go in and fix that. Because I know I've seen other tools that they have multiple solvers, but they don't go to this extent to deal with these things in a semi-automatic way, by just saying, "Hey, I'm fluids. I need to mesh different." What about anybody else got something to talk about?
Well, yeah, I hate to be a one-trick pony, but I'm going to go with structural beams again.
I guessed that. But you know what? It's a pony that got you a long way in your career. So
It did. Yeah. So they've added structural beams around this time, and they're available for static, modal, random vibration, and of course linear buckling analysis.
Yes.
So there's visualization tools for bending moment, actual force, shear moment diagrams, etc. You can play with beam end releases, which is fairly big too.
Yeah.
And there's along with talking about the physics-aware meshing, there's physics-aware meshing for beams, so it defaults to dividing them up based upon beam length. And that's pretty nice to do automatically.
Yeah. It saves a lot of those. It's the same thing we were talking about in SpaceClaim. It just saves a lot of steps. So this is nice. You can set up your beams in SpaceClaim, and if you're not an Ansys pro, you can do quite a bit of simulation in Ansys AIM, which kind of steps you through the process a little bit more. Yeah.
Right. And then speaking of that, they've got shared topology for beams and beam shells like they do within SpaceClaim. So now you can do stiffened panels.
Nice. Which is there's a lot of things in the world. It's funny what you end up talking about when everybody else is discussing sports. We met up with a former colleague who now lives in Long Beach, and he's in the aerospace industry, and we're talking about lavatories on aircraft. And they're trying to get the weight out of the bathroom walls, but still make them rigid enough to where they don't, flop around when the plane flexes. And the whole conversation we had was about exactly what you were talking about, being able to embed beams inside these plates, because that's kind of what the structure is. You may not have known that for an airplane lavatory, at least the wall part of it. So
now you know.
So now I know that I could model that in AIM. I didn't have to go all the way to mechanical to do that. So that might actually be kind of useful for the design engineers at the company that he's consulting with, to be able to do some quick iterations on some novel ideas on how to stiffen all that up. Very interesting stuff. How about, let's see, Joe, you got one?
Joe already went.
Oh,
I already went.
Okay.
But I didn't go.
Oh, Ted didn't go. Okay.
So
Ted.
I'll say, the upgrade path for Discovery Live is AIM. So you can start in Discovery Live. And of course, Discovery Live, as we've been saying, is a designer tool. We're not trying to badmouth designers in any way. It's just, it's meant to give you quick answers on, what if I do this? What if I do that? Or, topology optimization, something like that. But, it's incredibly fast, but there's always a trade-off. And so once we have something that's looking feasible in Discovery Live, we're going to want to take it into a more accurate simulation tool. And the next step up is AIM.
Okay. And
from AIM, if needed, we can go into the flagship tools, Ansys Mechanical or Ansys Fluent, if we need to. But we can go directly from Discovery Live into AIM. And so there have been some enhancements in that process in 2019 R3. For example, distributed mass. You can apply a distributed mass in Discovery Live. That's a way to capture mass of some additional structure without actually physically including it in the model. And so that effect can come into Discovery AIM. And then there's a beta capability to bring in multiple load cases. So I think multiple load cases was added in Discovery Live 2019 R2, if I remember right. And now we can bring those multiple sets of loads into AIM for further simulation. And again, that's a beta capability at 2019 R3.
Cool. Has a lot there. And we just had this discussion about R2, and we're going to be talking about 2020 R1 soon enough. So I can't wait to see what they've got in there. We are running out of time, and I think we actually covered everything. I'll just add, totally out of my comfort zone, but I'll just mention it in case someone cares, that we have new electromagnetic results capabilities, induced voltage, and whatever flux linkages. Again, I'm showing my ignorance. If it's an electron, I don't quite get it, but I have to convert everything into a mechanical analogy, but that's been added as well. So again, this is a multiphysics tool from the ground up, and they're adding those capabilities in there as time goes by. Any parting words from anybody before we sign off? Nope.
We're all being engineers, I guess.
Everybody's happy. I said what I needed to say. I'm not going to fill up. Yeah, but the nature abhors a vacuum, right? We will. The webinar is going to be. Is it next week? I should have looked that up before I got on.
Yeah, the
20th. So you will be presenting that at 11 o'clock Mountain Standard Time. Daylight Saving Time is over, so we're back on Mountain Time here in Arizona.
We're always on Mountain Time here in Arizona.
We're always on Mountain Time. There's also other people that change a valid point.
We're standard.
We're standard
by definition.
We were standard by definition. We don't need more daylight.
Everyone else is finally back to the right time zone.
Everybody's right back to they're all back to normal now. Now a more important question is this freeze that's headed its way through the middle of the country headed down to Houston, or are you guys still fairly warm there?
Oh yeah, tonight it'll freeze. It got close last night, but yeah, tonight it'll freeze.
Well, you enjoy that. I'm sure you'll still be able to do the webinar in a week. It won't ice over too much, and if it does, as long as the internet works, we'll be fine.
So don't tell anyone, but the last I checked here in Tempe today, it was 79 degrees.
Yeah. It's this is our time of year to really feel good about living in the desert. Yeah,
we've paid our dues all summer long, and now we're reaping the reward.
Yeah,
that's why we need to get outside. We need to be done with the
I know we need to get the podcast and go walk around the lake. There's a lake right next to PADT, and a lot of us like to walk around it, especially this time of year. So thanks, guys. It's so great it's so much better when I get as many of you as we did. I think we covered everything really well, and hopefully the users learned enough to go and play with these new features. As always, read the release notes if you want to know more. Reach out to us if you have any questions, and definitely attend the webinar. And if you can't attend it live, you can always watch the recording. Just register, and they'll give you access to the recording on Bright Talk. And thanks, guys. We'll hopefully talk to you soon, probably before too long, about R1 for 2019. Thanks. Or 2020.
2020.
Yeah. I could hear the silence of he said the wrong thing. Thanks, guys.
Bye, guys.
Bye.
Bye.
So as you can see, there's a lot of good enhancements that impacted a lot of users. It's always fun to have these discussions and kind of learn new things and kind of poke into areas of the code that some of us don't spend a lot of time in, or we just kind of use it the same way we've always used it and don't look at these new features. As mentioned, we'll have a webinar on the topic on December 20th at 11 p.m. or 11 a.m. Phoenix time. That's Mountain Standard. So go to Bright Talk and search for Ansys or PADT, and you can find this webinar and many others. And as always, you don't have to listen to it live, although we prefer that. You can always listen to the recording. Just register just the same. I'm going to spare everyone from listening to one of our commercials. I'll admit they're getting a little old, and they're probably losing their impact. Those of you who've been listening to the podcast for a while may just tune them out or skip over them. And those of you new might kind of scratch your head. We did those as kind of a temporary thing, and then they lasted 50 episodes. I will say that we are working on some other options in the future. Until then, let me say this. Please consider PADT for all of your Ansys training, consulting needs, and for sales and support if you're in Texas, New Mexico, Colorado, Utah, Arizona, Nevada, or California. Basically, if you're in the Southwest, we can sell or support Ansys for you. And if you're anywhere else in the world, we can do consulting and training as well. Also, don't forget that other parts of PADT are famous for our 3D printing, our product design. We also do scanning and a host of other services that mechanical engineers need. So we're here because, as our slogan says, we make innovation work. So please consider hiring us or buying from us. Thank you. So let's talk about the Ansys stock. We're just going to talk about it and the Q3 release information. The stock right now is sitting at $235.15 at the close of the market, which is today's November 15th, which is a Friday. It peaked today at an all-time high of $235.58. So that is amazing. That's 66.38% growth year to date since January 1. And the market also reached an all-time high today. The S&P 500 has grown since January 1 by 26.4%. So Ansys still continues to outperform more than double what the S&P 500 is doing. So that's fantastic. This puts the Ansys market cap at over $20 billion. That's the B. So if any of our listeners are thinking about buying Ansys, not a few shares, but the entire company, or at least controlling interest, you just need a little over $10 billion for controlling interest. I'm not advocating it, but, Bill Gates, if you're looking to add something in your portfolio, that's what it's going to cost. You can afford it. Please don't. We like the current ownership. We like being a publicly traded company. It's working out really well for everybody. If you want to compare Ansys to Altair, which is the other simulation-focused publicly traded company, they didn't have a good November so far. They dropped recently almost 20%. I didn't quite do the specific math, but about a 20% drop since the beginning of the month. They're down to $28.88 a share, which is 12.7% growth year to date. So that's less than half of what the S&P 500 has done. So they're not doing as well as Ansys for who knows why. I really don't know, but it gives you kind of a comparison of how well Ansys is doing. So let's talk those Q3 numbers. Every quarter, publicly traded companies have to put out a statement of what they did over the previous quarter, and then they often get on the phone and talk to people. I won't talk about the phone call. There's nothing really surprising there other than the numbers, which are really good. No big reveals, but we'll definitely listen to the recording for the year of 2019 and report on that once we've got a chance to be in February at some point next year. But before we get started into the actual numbers, let me just point out that Ansys reports two kinds of numbers, GAAP and non-GAAP. GAAP is what's called general accounting principles, and non-GAAP is not general accounting principles. I'm going to report the GAAP numbers because they come first, and I don't understand what the real difference is between the two, but that seems like a good place to just be consistent. So these are GAAP, GAAP numbers. Revenue for Q3 was $344 million. That is $1.04 per share in earnings. And that delivered a profit margin for the quarter, for Q3, of 30.5%. I remember celebrating when Ansys crossed the revenue mark of $1 billion for an annual. That was a big goal, to get $1 billion in annual revenue. Well, they just did $1 billion in the first 3 quarters of 2019. So congratulations to everybody from technical support to sales to the developers, especially developers, to senior management, to the people that stock the machines in the cafeteria. What an amazing thing to get to $1 billion in 3 quarters, and very exciting. Q4 is usually a good quarter for them, so who knows where they're going to end up. They've got year to date, their profit is $285 million, which is 32% of that revenue. And cash on hand sitting there in the bank right now is $732.9 million. So they certainly got a lot of cash on hand still. I'll probably, when we do the full year, we'll look at, where's money coming from? Is it the sale of new seats? Is it the sale of old seats? What revenue streams are important? But what I can tell you, just looking at the first 3 quarters, is that it's a nice, healthy mix. $431 million of that revenue, that a little over $1 billion in revenue, came from maintenance and services. And let me just make sure I get this right. $431 million. $431 million. I got that wrong. $431 million was new license sales, and $598 million was renewal and services, maintenance and services. And that's 41% and 58%. So it's a nice balance, right? You want to make sure you've got money coming in the door for maintenance and to keep the lights on, and then you want to see growth as well with new business. So it's really powerful to see that. What does it all really mean? My non-expert opinion is that this is a very healthy company financially that continues to grow well. Consistently seeing good growth. They're making money and investing it in people and technology. Some of it by acquiring companies that have people and technology, and some of it by putting money into hiring people or putting money into programs for research. We're seeing they're not resting on their laurels at all. For users, we just talked, our discussion went long because there were so many cool new features in the software. Just that one little small corner of Ansys saw all these improvements. A healthy company allows that to happen. They're not cutting back and skimping. So expect that to get only better, I hope, as time goes by. I don't have any inside information. I'm not an expert. All the things the lawyers want me to say, this is just my opinion, looking at the same numbers you can if you just go to the Ansys website and read their press release. Speaking of the Ansys website, I'm going to skip. We've gone long, so I'm going to skip the blog and such. We'll catch up on that in the next podcast. Upcoming event-wise, here at PADT, we're kind of winding down. It's coming up to the end of the year. It's mid-November. So the one event I want to make sure everybody knows about, at least our listeners in Arizona, is that if you are in Tucson, if you're not, you can drive down. Please come to our Customer Appreciation Day, December 18th in Tucson. This will be, I think, the 4th year. It's the 3rd or the 4th year we've done it there in downtown Tucson. It's a lot of fun to just catch up with customers, and everybody gets to talk with each other. And we usually get between 30 and 40 people to show up. And it's rare that you get that many Ansys users in a room in a small town like Tucson. So it's a great experience. So please do come by. Even if you're not an Ansys user, it's for all of our customers in Tucson. One other bit of news that I'd like to share with you is that last night, PADT was recognized as one of the top 50 privately held companies in the state of Arizona. The ACE Award is the Arizona Corporate Excellence Award, and I really want to thank all the sponsors and judges for putting us in with so many great private companies. You win these awards and you're like, oh, that's pretty cool. And then you look at the other companies that you really look up to that may be customers, that may be companies that you know a lot about because they're doing some great things. And seeing our name in that list of those 50 companies was pretty special. And we're really pleased to be part of that. The other thing that was really nice about it is it's not a tech-oriented award. We usually play well with other tech companies. We're well known in the community because of our activities in the tech community here in Arizona. So to get an award from normal business people, let me use that term, rather than a bunch of engineers or software developers, was really special. We competed with thousands of private companies. Everything. One of the winners does asphalt, and the other one is one of the largest MRO. They repair jet engines and aircraft in the world. So, we're in with some great people. So I want to take just a little bit of time on this podcast to thank everybody involved, our employees, our customers, as well as everybody involved with the ACE Awards. So we're really pleased. That was our third award for the year and for our 25th anniversary a year. So it was a really nice way to close out that 25th anniversary celebration last night there in Scottsdale at the Center for Performing Arts, which was a great venue. So in conclusion, I want to thank all of you for listening. It's an important part of what we do is knowing that you care. We keep running into people that say they listen to the podcast, and we love to hear that. Don't forget to subscribe at www.padtinc.com/opt-in. Spread the word. Let's get those numbers up, and don't hesitate to reach out with anything and everything. Thank you for joining us for the All Things Ansys podcast, episode number 51. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.